Welcome to the last session. This session will be on Redox, okay? The final session of 8, so this is the 8th session. And we're not going to be speaking about redox chemistry overall. We're just going to speak about how to balance equations in redox chemistry so that you can then use it to work out moles. So what is a redox reaction? A redox reaction is a type of chemical reaction that involves a transfer of electrons between two species. An oxidation-reduction reaction is any chemical reaction in which the oxidation number of a molecule, atom or ion, changes by gaining or losing an electron. This gaining or losing an electron, sometimes you might not visibly see it. For example, CH4 plus O2 to give CO2 plus H2O, you might not realize that carbon has been oxidized there, but there is transfer of electrons, okay? So how do you write a redox reaction? So there are two types of redox reactions, either in acidic conditions or in basic conditions, and they are very similar, okay? So let's start with the acidic conditions. And then for the basic conditions, we are simply going to add one more step. So for a redox reaction in acidic conditions, first, balance the atoms. Once the atoms are balanced, balance the oxygens by adding H2O. Then, to balance the hydrogens, add H+, you balance the charge by adding electrons, and then you balance the electrons by doing some cross multiplication. Rather than explaining them here, why not go into an example and see what we can do? So here we have an equation of methanoic acid with permanganate to give carbon dioxide and then Mn2+. So let's delve into this. Let's start MnO4 minus to give Mn2+, methanoic acid to give CO2. Okay, so let's take a look first. Are the atoms balanced in the first reaction? And manganese, you have one of each. So then we look at the oxygens. So we need to add 4H2O. Once we add the 4H2O, we realize the hydrogens aren't balanced anymore. So we need to add 8H+. Once we add the 8H+, then we need to add the electrons. So we look at the charges. So we have 7+ on the left and 2+ on the right. So to get from 7 to 2, we need to add 5 electrons. And remember, electrons are negatively charged. Okay? And now we would be having a 2 charge on both sides. For the second one, okay, we start with balancing the carbon. It's balanced. Once the carbon is balanced, we try to balance the oxygens. It's also balanced. So we only have to add the H+. And once you add the H+, the charges are not balanced because one is 0 and the other one is +2. Therefore, we would need to add 2 electrons. Now, once you do this, once you get to this position, you realize the electrons are 5 and 2. So to get 5 and 2 to the same base, it would have to be 10. So we need to multiply the first reaction times 2 and the second reaction times 5. At this point, you can choose to either do this mentally or else you can actually opt to write them all again. I don't mind which one you use. I feel it's not important which one you use as long as you get the right answer. In my opinion, okay, I would normally copy the 2 reactions and write them out again, okay, because this should minimize mistakes. But if you feel comfortable not to do the step, then feel free to do that, okay? If you feel comfortable not to do the step, then it's not a problem. Okay, and at this point we'll note that the electrons will cancel out and the H+ will also be reduced to 6H+. Okay, it will also be reduced to 6H+, and then we can copy our final answer. So it will be, we add them up, 6H plus 2MnO4 minus plus 5HCOOH to give 2Mn2 plus 5CO2 plus 8H2O. And that is your final balanced answer. If you were to have a basic conditions, you would be doing the same steps. So balance the atoms, then you balance the oxygens by adding water, then you balance the hydrogens by adding H+, then you balance the charge by adding electrons, and you do the cross multiplication and balance the equation. But then you add OH minus on both sides until there are no H plus in solutions. Okay, until there are no H plus in solution. So we have an example here. Let's delve into it. Okay, so CrOH 3 times to give CrO4 2 minus and Br2 to give Br minus. Okay, so let's do the first one first. Start off by balancing the atoms, so chromium are the same. Then we can balance the oxygen, so we need 1 water on the left. Once we balance the oxygen, we realize that the hydrogens are not balanced, so we will require, okay, to add hydrogens onto the right side, and there will be 5 hydrogens, okay? And now we'll note that the electrons are not balanced. The charge on the left is 0, the charge on the right is 3, therefore we need to add 3 electrons. Same thing will need to be done for the bromine, though this looks like a little bit simpler, but this is a situation where the atoms are not balanced. So here, in fact, you will need to balance the atoms. Once it is balanced, the oxygens, there are no oxygens, hydrogens, there are no hydrogens. Therefore, we just balance the charge, 0 and minus 2. So we need to add 2 electrons to the left side. Okay, at this point, we realize that you have 3 and 2, so the common denominator is going to be 6. So the top one will be times 2, the bottom one will be times 3. And as we did before, we're going to write the equations all together. Okay? And we do this to try and minimize mistakes. Okay? Now, it might look like it's going to take you a lot longer. And in theory, it might. But it will save you making mistakes. And I think that is more important in the long run. Then you add them. Okay, realize I immediately cancel the electrons because I know they will cancel out. But here, we need to note that we've got H pluses, so we'll add 10 OH minus on both sides. Okay, so these are going to cancel out to give 10 water. Okay, and those 10 waters will then cancel out with the waters that were present when it was under acidic conditions, okay, to give the final answer. And the final answer would be 10 OH minus plus 2 CrOH3 plus 3 Br2 to give 2 CrO4 2 minus plus 6 Br minus plus 8 H2O. And that will be our final answer. You have a few more questions of the sort in the description section. You will also have a few questions with respect to moles as well. So just balancing the equations. I've also given you a few questions to work out, and if you have any queries, please do not hesitate to ask me. And now, once you do those questions, you can say Deo gracias because you would have finished the whole session. Thank you for your attention, and I hope this was very fruitful for you.